All right, let's dive into a molecule that you probably think you know everything about: calcium. But I'm going to bet that its most critical job, the real reason your body is obsessed with it, is something you've probably never even thought about.
So let me ask you a quick question. When you think of calcium, what's the first thing that pops into your head? For pretty much everyone, it's strong bones, right? That's what we've been told our whole lives.
And look, strong bones are obviously super important, but that's not the main event. The real moment to moment reason your body meticulously controls calcium is all about one thing: electricity. And that brings us to our first big idea. You're about to see why managing calcium is like walking a high stakes tightrope, where even the tiniest wobble can have huge consequences. Okay, so let's get this straight. We're not talking about the calcium that's locked up in your bones. We're talking about the tiny, electrically charged fraction of it that's floating around in your blood. This is called ionized calcium, and it is absolutely mission critical. It's what allows your nerves to fire, your muscles to contract, and your heart to keep a steady rhythm. This isn't a slow, structural job. This is the electrical wiring of your body, happening every single second of every single day. And that tightrope I mentioned, man, is it narrow. If your active calcium levels drop just a little too low, a state we call hypocalcemia, your entire nervous system goes haywire. We're talking severe muscle spasms or even seizures. But if it goes a bit too high, that's hypercalcemia. It's the opposite problem. It acts like a sedative, depressing your nervous system and throwing your heart's rhythm all out of whack. So yeah, your body needs an absolutely bulletproof system to stay balanced.
So, how does it do it? How does the body solve this incredible balancing act? Well, let's look at the first line of defense: a simple brute force solution involving a massive reservoir.
I mean, the scale of this is just staggering. Over 99% of all the calcium in your entire body is stored away inside your bones. Your skeleton is, for all intents and purposes, a giant calcium bank, a huge savings account. But here is the absolute kicker. The entire complex regulatory system we're about to unpack, it's not designed to protect that 99% in the bank. Nope. It is all built to protect this tiny, almost insignificant looking fraction, just 0.1% that's circulating in your blood. That's it. That's how vital this electrical role is. And you know, if we zoom in even closer on that tiny fraction in our blood, it gets even more specific. Turns out only about half of the calcium floating in your plasma is actually in that ionized, electrically active form. The other half is basically on the sidelines, either stuck to proteins or other molecules that keep it inactive. So when we talk about keeping things in balance, we're really talking about obsessively controlling this 50% slice of the pie. Okay, so we've got a bank. But every bank needs a manager, right? Someone to handle the deposits and withdrawals. Well, that brings us to the really sophisticated part of the system. Let's meet the hormone team, our master regulators. And the captain of this team, the MVP, the first responder, is without a doubt parathyroid hormone. You can just call it PTH. This is your fast-acting, we have a problem hormone. Its entire job is to raise your blood calcium levels whenever they start to dip. So how does it do it? Well, PTH has a really slick three-point plan. First, it goes straight to the bone bank and authorizes a withdrawal, releasing stored calcium into the blood. Second, it tells the kidneys, hey, stop letting that valuable calcium escape in the urine. Reabsorb it. And third, it helps you absorb more calcium from your food. But to do that, it needs a partner. And that partner is good old vitamin D. Now, what's so fascinating here is that vitamin D isn't just something you get from the sun. It's actually a hormone that your body has to build in a three-step journey. It starts in your skin with sunlight, then it goes to the liver for a little tweak, but the final, most crucial activation step happens in the kidney. And it only happens when PTH gives the signal. Without PTH's go-ahead, vitamin D just sits on the bench, inactive. And once it's activated, vitamin D's main job is to head to your intestines and crank up the absorption of calcium from the food you eat. Think of PTH as the fast-acting sprinter for emergencies, while vitamin D is the marathon runner, working over a day or two to build up your long-term supply. All right, get ready for a really cool kind of weird plot twist in this story. You'd think that to get calcium out of bone, PTH would talk directly to the bone-dissolving cells, right? Well, it doesn't. The bone-dissolving cells, the osteoclasts, they don't have receptors for PTH. Instead, PTH talks to the bone-building cells, the osteoblasts. The builders then release a special molecular key, and that key is what unlocks the bone dissolvers to get the calcium out. It's a super clever, indirect handoff. This is all amazing, but how does the team captain, PTH, even know when it's time to act? Well, the body has this absolutely brilliant sensor system built right in. Think of it like a highly precise calcium thermostat. The secret sauce here is a protein called the calcium sensing receptor, or KSR for short. These are tiny little sensors that cover the parathyroid glands, and their only job, 24/7, is to constantly dip a toe into the bloodstream and measure the exact concentration of active calcium. And the genius of this feedback loop is its beautiful simplicity. The rule could not be clearer. If the sensors detect the calcium levels are dropping, they shout, "Release more PTH." If they sense the levels are rising, they say, "Okay, ease off, release less PTH." It's a perfect, real-time thermostat that keeps you on that tightrope. And I'm not just saying this is a pretty good system. It's widely considered to be one of the most sensitive and responsive feedback loops in all of human physiology. It can detect tiny, tiny changes and respond in minutes to keep that electrical balance absolutely perfect. Okay, let's bring it all home. We've seen the bank, the managers, and the thermostat. It's time to put all the pieces together and look at the final equation. There is one last really crucial piece to this whole puzzle, and it's a molecule called phosphate. See, PTH doesn't just raise calcium, it also actively gets rid of phosphate through the kidneys. And you might ask, why? Well, it's because if calcium and phosphate levels get too high at the same time, they can literally crystallize in your soft tissues, and that is a disaster. So PTH cleverly manages both to keep you safe. So this table right here, this is your ultimate cheat sheet. If you remember one thing, remember this. PTH is your emergency responder. It brings calcium up and pushes phosphate down. Vitamin D is your long-term supplier. It helps you absorb both from your diet. And that third one, calcitonin, yeah, it technically lowers calcium, but honestly, in healthy adults, it's a pretty minor player. The real dynamic duo is PTH and vitamin D. So we've just seen this incredible, elegant system that will do anything to protect that critical calcium level in your blood, even if it means robbing your own bones to do it. Which leads us to one final, very big question. If this system is so perfect, why are diseases like osteoporosis so incredibly common?